So today here is going to be the bell ringer. Remember, there's no talking to your neighbors until it's collected, and it's like a quiz. So I want to see what you know, not what your neighbor knows. And I'm going to move on, but please pause this video, and when everyone's done with the bell ringer, collect it, and then you can push play so we can get rolling with this lesson. So let's actually answer that bell ringer. So here is the answer to the bell ringer. So it says write an equation of a line that passes through this point. Okay, so we have a point, and it's perpendicular. Perpendicular is the key word here to this equation. Well, what do you guys know about perpendicular lines? If you're looking for a perpendicular line that has the negative reciprocal for the slope. So when in doubt, slope it out. We got to find the slope. So right now my slope here is at -2. And then if I do the negative reciprocal of that, I would take it as -2/1, you'd flip it, and now it turns into 1/2. And it was negative to start. So if we do the negative reciprocal or opposite reciprocal, it's now going to be +1/2. So my slope is 1/2. My point is here, and I'm going to use the point slope formula, which is y minus my y value equals m, and then x minus my x value. Two negatives here make a positive. I'm going to make this a plus. I will distribute, and you get 1/2x plus 3/2 or 1.5. And my last step is I'm going to minus the 6 to the other side, and I'm going to get y equals 1/2x minus 4.5 or 4.5 or 9/2. Would all be answers that could be 4.5. So you could add 4.5 here, you could have also had 9/2. Okay, and that is the bell ringer. So, for today's lesson, we are now moving on to the next section here, which is called, my computer works, parent graphs and transformations. So we've kind of dealt with it a little bit. Today we're going to learn about is what are the normal parent graphs that we can just look at it and know what type of equation it's going to be based on the picture, or based on what the problem has. We can determine what the picture is going to look like just looking at it. Okay, and the other thing we're going to talk about today are called transformations, where we're shifting or moving my equations, or doubling the height or stretching them out. So my learning goal for you guys today is to identify and use parent functions, and then to describe transformations of functions. So let's look at the y section here. Actually, if you guys want to know what page we're on so you can follow along, I do believe we are on page 109. So page 109 in your book is where we're at. Okay, so it says here, Nick makes $8 an hour working at Plaza Shop. The red line represents his wages. If he also delivers pizza, he is paid $2 more per hour. The blue line represents Nick's wages when he delivers the pizza. These graphs are examples of transformations. So he gets more money. If you guys notice, the slope on the blue line is steeper. He makes more money when he delivers because he gets the $2 per hour charge extra. Okay? And that's a linear function when they talk about functions. Alright, so here are the 4 types of parent functions. This is again on page 109. If you're following along there, you can probably see it a little bit better on your book than the screen, because the projector's not spectacular. Okay? So the first equation is called a constant function. And the way I remember what that's called is it's constantly staying the same height. So it will never change its height. So on that equation right there, it's a special line. It's a horizontal line that we've talked about a little bit in this class already. And it's the equation y equals 1 because it goes through the y-axis at 1. Every point that you would pick on that line, no matter what point you'd pick, the y value is 1 because it never changes height. So it's constant. It'll constantly stay the same. And you guys will have to know the 4 names of these functions, so then I would maybe start thinking about it and putting it to mind right now, because they'll ask you questions on this assignment here that we'll do tomorrow. The second one here is called the identity function. Okay, and the identity function is a function that has, it's just y equals x. Okay, and the slope is up 1 over 1, and that's the identity. So that's the original linear function. If it's not a flat horizontal line, then the parent graph of the other linear function is the identity function. Okay, and then from this identity, what they do is they will change your y-intercepts. So it will go up or down on my y-axis, and then it also changes the steepness of the line. So it could be steeper, or it could be less steep, depending on. And you guys did those lines at the identity functions on the assignment from last Friday, or this last week. Because those lines, remember, the one was steeper, the one was less steep, and you determined if the slopes were the same or different and stuff like that. So that was an identity function that you guys were dealing with, a linear function. The next parent graph function that we have here are called the absolute value function. Okay, and the absolute value function is the letter V, so it makes the letter V. So whenever you see the symbols for absolute value, and again, so if you ever see these symbols, Y, so if you ever see these symbols here, okay, instantly you should know it's going to make the letter V. That's automatic. And if you see the V on a graph, you know it has those symbols in the equation. Okay, so those are called the absolute value symbols. The fourth function that we're going to be learning about is called the quadratic function. Okay, and a quadratic function is, so it's called a quadratic. We've done those a little bit every once in a while here. So y equals x squared would be the parent graph. So whenever you see a square, you automatically know it's going to make a shape like that smiling face. And this smiling face has a special name to it. Okay, and it's called a parabola. Okay, so whenever you see an arc like that, it's called a parabola. So P-A-R-A-B-O-L-A, parabola. So you want to write that down, you can. So whenever you see the x squareds in your equations, we know that it's going to be a parabola. Or another name is the quadratic function. Okay? So now what we're going to do in this next slide here is I'm going to give you a picture, and you're going to have to say which of those 4 is this one, identity, absolute value, or quadratic. Which of the 4 is the type of function that we're given. Okay, so I want you guys to just look at this quick. Don't say it out loud. I'll give you 30 or 15 seconds maybe just to look at this and determine what type of function is that showing. Maybe not 15, but. All right, so instantly I notice it makes the letter V. So on this problem, since it makes the letter V, it's called absolute value. Okay, so this is going to be an absolute value, which, if you're thinking about it, is that symbol. You don't have to write the symbol, you just have to identify what it is. And B, on this problem here, it looks like it's the same flat line. Does not change, so it is constant. Constantly staying the same height. Alright, I'm going to give you guys 2 now. Alright, I want you guys on your paper quick. I'll give you 15 seconds. Write down 1a and 1b what you think those types of functions are. All right, does everyone have an answer? And what is the answer for 1A? Yep, it is called a quadratic. Now, if you wrote parabola, a parabola is the shape that it makes, but the type of function would be called a quadratic. Okay, and 1B's answer is? Correct. Well, they wrote linear. It is linear. I would have also had identity as the answer on that, because that's the type of function it is. But it is a linear function. I guess the identity function is the original, but it is linear. So they picked linear instead. But linear or identity function, which was the upper right there, would be the choices that you could have said. All right, take your paper out right now and write down this key concept. If you want to put pause on the slide, you can. I'm going to move on after that, so you guys can just pause it until they write it all down. Okay, so it says here the key concept. These are two sayings that you're going to have to use, and this helps you to determine if equations are translating or not. So it says here, if the number is on the outside, change the y value and do the same operation or with the same operation. So the y values are doing exactly what's happening in the equation. And then the second key concept would be if the number is on the inside, change the x value and do the opposite operation. Okay? And when they talk about, I'll explain it here and then you can pause it when it's all done if you don't have enough time. Okay, so if the number is on the outside, so what that means is I have an equation up here, y equals the absolute value of x plus 2. Okay, right now this 2 would be on the outside of the absolute values. If I had an equation, now this is not a part of this one, but if I had y equals x squared plus 2, this 2 is still on the outside. Okay? Now what's it look like if it's on the inside? This is what it looks like if it's on the inside. Notice it's inside the parenthesis. And if I did the inside here, it would be y equals the absolute value of x plus 2. Notice the 2 is now inside the grouping symbols. So inside is in the inside of the grouping symbols. Outside would be not a part of those grouping symbols. Okay? So an example of this, if you need to pause it now, but I'm going to move on. Okay, so an example of this says, graph the equation y equals absolute value of x plus 2. So we have y equals absolute value of x plus 2. So what they do, the normal absolute value will always start at 0. Okay, and the normal slope of the apparent graph of the absolute value is up 1 over 1. Up 1 over 1, up 1 over 1. If they don't have graph paper, it's in the left corner up here in the front of my room. You can grab that. Okay, or it's up 1, left 1, up 1, left 1. So this is the normal parent graph. So when you guys graph these today, okay, because it says describe the translation and then graph the function. So you're going to have to describe what happens and then graph it. Okay, so in this is my parent graph, this is my equation, that's what it looks. This is the line y equals absolute value of x. We now want to do absolute value of x plus 2. So what happens here, 2 is on the outside. So on the outside I changed my y values, that would be the up and the down. Okay, with the same operation. And the same operation means what's happening here between the absolute value and the 2 plus. So that means we're going to add 2 to every y value. So when it says describe the translation, I would say every y value adds 2, which means it goes up 2 units. Okay? So then every point I pick on this graph, I just put my pencil or my pen on it, and I count up 1, 2. Make a point. Go to the next point here, up, 1, 2, make a point. Go to the next point here, go up, 1, 2, make a point. Up from here, 1, 2, make a point. And I go over here, up, 1, 2, make a dot, and then up, 1, 2, negative dot. And then I connect them, and this is now my new equation, y equals the absolute value of x plus 2. Alright. Come on. Alright, so I'm going to have you guys on your paper try 2a for me, and then I'm going to do 2b with you. Okay, so on your paper right now, try 2a. So think about what parent graph that should look like on your graph. Draw the parent graph. And then it says on here, describe the translation. So figure out, where is that 3 located? Is it on the outside? Is it on the inside? Okay, again, that sentence that you wrote down, it says on the inside it's the x values and it's the opposite. So right now on the inside we have an x plus 3, so if you can't see, that's y equals the absolute value of x plus 3. So plus 3 again would mean it's on the inside now because it's inside of there. So we're going to change the x values, which those go left or right, because the x-axis runs left and right. Okay, and you do the opposite of what it says. So right now it says plus 3. So the opposite of that would be minus 3. So which direction would minus 3 be if I'm going to do that? And it's y, oh sorry. Minus 3 would mean it's going to go to the left 3 units. So again, I'm going to go to my original parent graph and just pick a point. So I'm going to take these points, I'm going to make them visual here. Okay, so I'm going to take all these points, I'm going to shift every point to the left 3. So 1, 2, 3. Okay, and there, and again, you go one by one, but every point goes 3 to the left. Redraw them, and I have my parent graph. Okay, I'm going to do this next one with you because we haven't done a parabola yet, and I want to make sure everybody does them the same every time. Okay, so I'm going to erase this here so we can do it. Okay, and again, I can put a graph up here, but you probably can't see my graph very well, but we're going to put it up here anyways. Okay, so here's my graph. And then my equation, if you can't see it, is y equals x squared minus 4. Instantly when you see a square, you know it's a quadratic or a parabola, which is going to make that parabola shape or that arc. Okay? And the thing I want you guys to make sure you do every time is you graph the arc properly every time. So if I have the equation y equals x squared, and I were to plug in, just do a chart here quick. Now, you don't have to make a chart each time. Once you do this, it's pretty quick. If I plug in a 0 here, what's 0 squared? 0 times 0 is 0, so 0, 0 would be the first point of my parent graph. What's 1 squared? So you plug in a 1. 1 times 1 is 1, which means you go over 1, up 1, place your dot. And then what's 2 times 2? So 2 squared. 4. So you're going to go over 2, up 4. And then my other one that I need to mark here is 3 squared. What is 3 squared? 9. So over 3, up 9, place a dot, and that's going to go off the graph on the 4, because 16 isn't on my graph. But I can also do what's negative 1 squared. Negative 1 times negative 1 is a positive 1. You notice that's a mirror image there over the y-axis. And then negative 2 times negative 2 would be a positive 4. Again, a mirror image across the y-axis. And then negative 3 times negative 3 is 9. Okay, so I now have my parent graph that I just graphed. So whenever you do a parabola parent graph, and you try to make that as smooth as possible, try not to make it a point to make it look like a V, but try to put a curve on it. Okay, that is the parent graph and how I graph the parent graph every time. So you don't do this chart just 0 times 0 is 0, 1 times 1 because we're squaring it, and then you can have your parent graph. So now that I have my parent graph, right now I got a negative 4. Where is that located? Is it inside or the outside? And it is on the outside, which means on the outside we change my y values and you do the same operation. Y values go which direction? Up and down, because the y-axis runs up and down. And you do exactly what it says here. So since it says negative 4, which direction would that be? Down 4. So this parabola is going to go down 4. So now once you have your parent graph, take every point and just count down 4, make a new mark. Take another point, count down 4, make a mark. So I'd go here, 1, 2, 3, 4, make a mark. 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 9, 8, 7, 6, 5, make a mark. Okay, and that's a mirror image on the other side. 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so in this parabola, and again, once you draw them in, connect the dots. Okay, and that would be my new translated equation. Questions? Alright, so the translations I think are the easiest. These ones get a little bit more complex, but not bad. Okay, so the next one here is a reflection. So it flips your graph. So on this example 3 here, it says describe the reflection in y equals negative x squared. So instantly you see negative x squared. We know what shape is it going to make. It's going to make a parabola. Okay, so it's got this original parabola, which again you do the same things as in the last one. X squared would be 0 times 0 is 0. 1 times 1 is up 1 over 1. 2 times 2 would be at 4. And then 3 times 3 would be up to here at 9. And again, it makes this parabola here. And you do the same thing. That's a mirror image of heights on the other side. So there's my original parabola. Okay, now it says y equals negative x squared. So we're using that same chart that we wrote at the beginning of the day. If it's on the, we did a sentence, but another thing I've done before in the past is I can do yx, outside, inside, same, opposite. So is this negative on the inside or the outside? And so this would be on the outside. So this is outside right now. If you want it inside, you have to put parentheses around it and group it, and then it's inside. So this is on the inside. The one we have though is on the outside. Okay, so on the outside, well let's think about it. It's on the outside. The y values are changing, which means it's going to go up or down. So up or down. Okay, and it's going to be exactly the same as what's happening. So well, what's happening? There's a negative 1 that is being multiplied to every y value. Okay, so let's just take this coordinate. What's the y value here at? It's at 1. So we take that times a negative 1, because that's what's going on outside here. 1 times negative 1 would be negative 1. And I do the same thing here, negative 1. To pick that 0, 0 times negative 1 stays at 0. What's the height here at? The y value? 4. Take it times a negative 1. We are now at -4. So then this height reflected down here. And then this height will reflect down here. Okay, does everyone see how that makes a reflection? And that would be my new graph here, reflected. Questions on that? So that's the reflection over the x-axis. So if it says describe the reflection, it's reflected over x-axis. Okay, because it goes up and down. Alright, so I want you guys to try both of these equations. Describe the reflection of each function and then graph the function. So I'll give you a little bit of time here. Draw the parent graph first, and then draw what happens. And if you can't see it, I'll write it down here. It's in your book too. Okay, so there's the one equation, and there is the other. So I'll give you a little bit of time to do that one here. Alright, I'll do 3A and then I'll give you a little bit more time to do 3B. So again, I'm not just drawing a random absolute value here. I know that on your guys' graph paper it goes to the corners. So where this corner is and this corner is, that's up 1 over 1. The slope is up 1 over 1, so don't just sketch a V and call it good. But if you wanted to, every time you can know that it goes from the origin to this corner of your graph every single time on both of those. Okay? So graph it properly each time, but I know what it looks like, so that's why I just drew it like that. And so the question is, where is this negative located? Well, it's very similar to the one I just did. It's on the outside, so the y values change. So pretty much every y value goes from, multiplies by a -1 because it's the same operation. So every y value multiplied by negative, which means this y value is at 0. 0 times -1, 0. This y value would be at 1. Well, now it turns to -1. So that you can see that this is going to reflect this direction, and then this side. And again, now that's a bad drawing on my part. If you had that, I wouldn't accept it. Okay, again, where should these go? From to the corners. And again, the slope is the same, down 1 over 1. It's the opposite now of what it was. But so the blue graph there would be my new function. Describe the reflection. It reflects over the x-axis. Okay? Alright, I'll let you guys do 3B now. Now, another thing you guys can do on 3B is, so these ones here, what type of function is this? I should ask you guys that first. Okay, and this is a linear function or the identity function.